Today's sections we're going to talk about similar triangles. So how can we tell if two triangles are similar? The most important thing to be similar triangle, that your angle have to be equals. The side itself don't have to be equal, like it's necessarily the same size, but the first right here, it say the angle have to be equal, right? And also corresponding side will have proportional side. So let's look at that. Example 1, explain why the given triangles are similar, right? So you need to make sure in order to prove these two triangles are similar, they have all same angle and also proportionally equal side. So then let's look at example A. You have two triangles. The first one is going to be the larger one right here. This is the first triangle. So triangle ABC, right? And then we have a second triangle right here. This is the second triangle that we wanted to look at it. Those two triangles, I will say they are similar. The reason I say those two triangles, which is going to be ABC versus ACD, is going to be similar because, let's write down, one of the angle that you have is the right angle. So this angle right here is right angle. This angle is right angle. So if I wanted to write that down, it's going to be angle BCA is equals to angle ADC as 90 degrees. So one angle is same. And the other angle is same is when you're looking at angle BAC is going to be same angle as angle DAC, right? So let's see which angle we're talking about. Both angles have the same angle right here. So this angle, wait, let me use the same line. So this angle right here in a triangle is overlapping as this angle, right? So you have angle A same. It means if two angles are same, the leftover angle have to be same. So in other word, angle B should be same as angle ACD, because that's the leftover angle from those two triangles. So let's say that angle ABC is going to be equals to angle ACD. So if three angles are same, your lengths should be proportional. Your side AD over CD should be proportional as DC over DB and AC over BC. Second example, we're going to look at to see if triangle ABC is similar as triangle ADE is. And then similar angle sign is sometimes different in different textbook. So I use this sign, but this textbook also use just a sign like that as the similar triangles. So again, different textbook have different notation for it. And let's see, so in order to be similar angle, a similar triangle, don't forget that all three angles have to be same and look like the angle ABC is equals to angle ADE, and then angle ACB is equals to angle AED. That's given, right? That's given. So you have this green as the two same angle, and you have those red as the two same angle, right? These two red as the same angle. And also, these two triangles have the same points, which is going to be same angle for angle A. So let's write that also. That angle DAE will be same as angle BAC. So since they're all same angle, this two triangle is going to be similar triangle. The second example we're going to look at is same thing as example 1, but we're doing one more step to find the missing links. So we're going to verify that two triangles are similar by showing all three angles are same. And then using the proportional links, we're going to find the missing links. When we're looking at A, let's see, we know that these 2 points is given as the same angle. And then because this 2 is vertical angle, we know that's also same. Out of 3, if 2 is same, then the other one must be equal angle also, right? Because adding 3 angle, you have to have 180 degree. So I'm going to draw the triangle so that I can compare the side. I have the smaller triangle look like that with B, A, C. So with the larger triangle, I wanted to draw the same angle in the same location, so I know that which side have to be proportional to what other side. So then I have to have C here, and then E there, and D here. So the side that I have to proportion, let me write down what's given links to. So this is going to be 7 inches between A and B, and then this is going to be 5 inches between B and C, and I have CE. CE is going to be 8 inches. My unknown is going to be the length of DE. So if you wanted to write this proportionally, I have to have 7 matching the X, and then 5 matching the 8. And both numerators come from the same triangle. So 7 come from the smaller triangle, so 5 should be on the numerator, and 8, the larger triangle, should be on the bottom. Once we set it as a proportions, Then we use the cross multiplications to get rid of the fractions. So we will have 5 times x equals to 7 times 8, which we get 5x equals to 56. And when you're dividing both sides by 5 to isolate x, you get 56 over 5, which is going to be 11/1/5, and your unit is going to be inches for x. So that will be the missing links of that larger triangle. We're going to try one more time with example B. So we're going to make sure this two triangle is going to be same. So the same, I mean not the same, but the similar, right? Similar if all these angles are same size. So look like this, given as 90 degree, 90 degrees, so that's equal. These two have the same angle notation, so this two is equal. And that means the leftover will be also equal. And we know that's equal because it's a vertical angle too, right? So those two angles are equal. So we know this two triangle is going to be equal. So now what we need to do is I wanted to draw it into the same shape so I can see which side is proportional to what the other side, right? So this way I have 8 centimeter and 10 centimeter, and I have right angle right there, and this two angle like that. So this should be the right angle, and this angle should be one with the dash between. That's the vertical angle, right? And I have 12 centimeter between right triangle and the other one, right? So that will be 12 centimeter. The x should be the vertical angle and right angle. So x should be proportional to 10 centimeters. So then when we write this into the proportional, we should have x with 10 centimeter. And since I put numerator with the bigger triangle links, 12 should be on the numerator. And that 8 centimeter from the smaller one should be on denominator. We just wanted to make sure the top number come from the both top number come from the larger triangle, and both bottom number come from the smaller triangle. So then we use the cross multiplications to get rid of fractions. And we do 8 times 8 and 12 times 10. And that gives you 8x, and that will be 120. Dividing both sides by 8 to isolate x, you get, that's going to be 15 centimeter. So if these two triangles are similar, then the x length should be 15 centimeters. Example 3. A man who is 6 feet tall is standing 10 feet from the base of the lamppost. The man's shadow has a length of 4 feet. How tall is the lamppost? So let's see if I can picture this. Let's say we have lamppost, and then in front of 10 feet, man is standing. and have shadow of 4 feet. And the question is asking how tall is lamppost. So this is the height they wanted to know. This problem is where I can use the similar triangle problems. The first triangle that I'm going to use is the triangle of the lamppost. So this is the first triangle. And have the right angle right there. And the length of 14 feet. And X value is what you're trying to look for, the height. The second triangle I have is this triangle, where the height of the person is 6 feet and shadow is 4. So if we wanted to write the proportional, the 4 feet should be matching 14 feet. So 4 come from 14. The height, X unknown, should be proportional to the height of the person. And since the numerator from the first fraction comes from the smaller triangle from the person, I will write 6 feet on the numerator and X on the denominator. To the cross multiplications, I get 4x equals to 6 times 14, which you get 84. And when you're dividing both sides by 4, you get 21 feet. So the height of lamppost is 21 feet.